By the end of this module, you will have a basic understanding on stairwell pressurization application, how it works traditionally, and Danfoss solution. The key benefits of using a VLT, HVAC drive, in stairwell pressurization systems. Let me start the module with a brief description of the stairwell pressurization application. Multi-story buildings have stairwells that serve for routine building access and emergency exit in the event of fire. To provide a smoke-free evacuation path during a fire, the movement of smoke must be controlled using a pressure difference across a door. The high-pressure side of the door is the refuge area, or escape route. Airflow through the gaps around the door prevents smoke infiltration to the high-pressure side. Pressurized smoke-free stairwells also provide a staging area for firefighting personnel. Stairwell pressurization, with dedicated fans and control, is the preferred method of control. Pressurization can be supplied by a single or multiple injection supply system with a fan located at the top or bottom of the stairwell. Single injection systems supply air into the stairwell at one location and can fail when a few doors are open near the air supply fan. To overcome this problem, air is supplied at a number of locations over the height of the stairwell with multiple injection systems. These systems are superior in dealing with the variability of smoke effect and the unpredictability of door openings and closings in the stairwell. In event of a fire, the fan operates to keep the stairwell smoke-free. However, this can lead to overpressurization in the stairwell chamber, making it difficult for the doors into the stairwell chamber to be opened. The maximum and the minimum pressure differences between the stairwell and the building should be considered. The minimum pressure difference should prevent smoke entry into the stairwell during evacuation, when many stairwell doors are open and a ground-level door opens to the outside. The maximum pressure difference should not cause the excessive door opening force when all the stairwell doors are closed. We shall now look at a traditional stairwell pressurization system. The problem of overpressurization has been traditionally addressed by the installation of a mechanical pressure relief damper in the stairwell wall. The pressure relief damper opens when overpressurization occurs. Let me show you how this is done. Take a look at the illustration. It shows that, due to high pressure, the doors are difficult to open. However, when the damper opens, the pressure reduces, and the doors are easier to open. The pressure relief dampers require regular maintenance to ensure they remain in a good operational condition in the event of fire occurring. We just saw the traditional solution and found that the pressure varies with the opening or closing of stairwell doors, and there is a potential overpressurization upon opening the door. How can we overcome this problem of overpressurization? That is where Danfoss solution comes into play. In Danfoss solution, the installation of VLT, HVAC drive, is perfect for stairwell pressurization applications. This is a life safety application, and the design should be carried out in conjunction with the design professionals familiar with national fire protection codes. The purpose of stairwell pressurization is to provide a smoke-free evacuation path during a fire. Smoke must be controlled using a pressure difference across a door. Differential pressure is the variable that prevents smoke migration into the stairwell from the building. It is used because the pressure measurement must be a differential measurement between the stairwell and the building. Stairwell pressure is referenced to the building rather than outdoors to minimize wind effects on the sensor. A minimum differential pressure should be provided to prevent excessive door opening force. Pressure fluctuations in the stairwell occur frequently and are nearly instantaneous with the opening or closing of stairwell doors. Directly connecting the sensors to the VLT HVAC drive enables it to rapidly change the speed of the fan to safely compensate for the opening of doors without creating the problem of overpressurization. Let me show you how this is done. Take a look at the illustration. When the door is open, the pressure is reduced. Then, the VLT HVAC drive increases the speed of the fan, maintaining the pressure constant. The speed of the fan is decreased as soon as the door is closed. The use of the two-input PID controller in VLT HVAC drive allows the monitoring of differential pressure at 2 points in the stairwell, improving the performance and the reaction time of the system. Typically, the two sensors should be installed above and below the neutral plane, that is the point of balance between buoyancy, stack, and wind effect. Separate set points can be for fire and normal modes of operation. In the event of fire, the safety of evacuation route is automatically ensured, eliminating the need of mechanical relief damper. Let us summarize the main benefits of using a VLT HVAC drive in stairwell pressurization system. The VLT HVAC drive maintains a positive pressure in the stairwell. Two-zone PID improves performance and reaction time of the system. In the event of fire, the safety of evacuation route is automatically ensured, eliminating the need of mechanical relief dampers. Before ending this module, let me give you a brief summary of what we learned. In traditional method, we have seen that pressure varies with the opening and closing of doors, and there is a problem of overpressurization, addressed by the installation of a mechanical pressure relief damper in the stairwell wall. But we saw that, with Danfoss solution, the VLT HVAC drive rapidly changes the speed of the fan to safely compensate for the opening of doors, without creating the problem of overpressurization. We also saw the key benefits of using the VLT HVAC drive. The VLT HVAC drive maintains a positive pressure in the stairwell. Two-zone PID improves performance and reaction time of the system. In the event of fire, the safety of evacuation route is automatically ensured, eliminating the need of mechanical relief dampers.